Okay, good. All right. So I think it is 6 o'clock, so we'll get started. So again, welcome to 6101. This is the lab rotation course for PhD students, but it's also our CP 3108 A and B for undergraduates. And it is a public course, so we have participants from outside joining us. So just to recall, one of the things I asked you guys to do is in this worksheet, which you can get to from SOC N.US, sorry, 6101-T2510, which is our semester, and then dash sheet, which is also in our general channel. So if you go to the general channel, go to bookmarks, you can see it right here. It take you to the same place as what we just you're supposed to write down your notes, and then also give which lectures and support we share. Now, as I already pointed out, those of you who are taking the undergraduate course CP 3108A for 70 to 100 hours, you have to choose one lecture, and that's the same for external purposes. Okay. If you're auditioning for work in our group, you can also, I think, choose that. And we have a couple of participants from the university. So from my found will also cover that. Okay. So again, external participant, other NUS students, CP 3108 student, you're responsible for one lecture and one support. So you need to choose one you want, and then I will assign. So I'll go over this later. If you're from my group, okay, or a CUP 3108B, like it says here, then you have to pick 2 lectures and 2 support talks. Okay. So if you're a mix of different things, then you comment let me. For example, I think there is one person, Josh Sheng. Josh Sheng is here. You need to let us know whether you're taking it for A or B. Okay. Now, you've done all of your selections, and I'll go over again how we're going to do the lectures. They will example that. Okay. But I have a pivot sheet, which shows you which lectures are very popular for people to bid from. Okay, so a lot of people want to talk about vector stores, prompting, would like to support the multimodal drag lecture. But of course, my job is to make everything as flat and uniform as possible. Okay, so I've assigned roughly 6 participants for the first half, because when we get our 6101 students from PhD group, many of them will be coming from the second half. Okay, so we're trying to make it as even distributed. Okay, and for that reason, you need to consult your name and the role that's listed here. Okay, so let's say I'm Ben. Ben Go, are you here? I think it's online, I'm not sure. Okay. But if you were Ben, you would have to check here that in fact he is allocated to week 5, the training, supervised fine tuning, context learning scale lecture. Okay. And also allocated to support week 12, the source credibility assessment. Okay, and so with this, you need to go back to Slack, okay, and go to the channel browser, okay, browse channels, that's here, okay, and then you search W05, which is the lecture that he's supposed to present, okay, join this channel, okay, W012 is another channel that he's supposed to support, so you have to join that channel. So those of you doing CP 308B for 4 units will have to join at least 4 channels, 2 for support, 2 for lecture. We don't allocate you to the same week when you're doing lecture and support, so that's 4 unique channels that you have. Okay, what we'll do there is to allocate duties for that. So I'm going to go over roughly how that works. Okay. So again, you might want to try to remember this prefix SOC-NUS, CS6101-28510. Then you can put a number of different suffixes to get to the resources that you want. So our Google Drive has a number of different things in it. The first one is the support goals, which I created today. This tells you what types of support release that you have. So if you're not sure about that, please go through this and then you can select the role. Again, the people who are assigned support role, you have to deconflict. There can't be 5 coordinators and nobody actually work. Okay, so that's part of one. Okay, so once we assign a role for these things, then I will help you carry them out. We'll be on all the prep channels. And my job is not to teach, my job is to scaffold. Okay, just make sure people are doing what's needed. Okay, so the lecturers, because when you do the lecturing, you have to stand in front of class as myself and Haitao today. Okay, and you have to give the lecture. There's a question, where do papers come from? So there's also a paper list. Not surprisingly, it also uses the same prefix, right? Papers. Okay, so you can do this. Papers. I can type it properly. Okay, then you'll come to Haitao's brag collection of papers. Okay, and it is something that this group has also kindly made available to us, meaning that you are supposed to issue pull requests to update this list. Okay, so these are seed papers, meaning they're the very top level information that when you give a lecture, you should first consult this list of resources. Many of them are tutorials. Okay, some of them, the tutorials themselves will have pointers to individual papers. And then these are the individual papers we summarize and present during class. Okay, so we will do the same for you. All right. So again, we have 5 lectures. What we need to do is then separate the duties over 5 or 6 people, about roughly an hour and a half. That comes to 15 minutes per person. Okay, when everyone have a chance to stand up in front of class or present from remote. But we have again right now, I think 8 people remote. Okay, who can give lecture. Okay, so when you give lecture remote, it's no different. You can be sitting, okay, whatever, but you will have to make sure you have a microphone, at least a webcam, so we can see a likeness of you. Okay. Any questions so far? Okay, so typically you'll have between 4 or 5 different sections of lecture, and our slide template that's in the drive gives an example of that. So what you can do when it's your turn to give a lecture, the lecture coordinator among all of you giving the lecture, one person can coordinate. Their job is mostly just make sure the lecture happens appropriately. So you'll have a coordinator, somebody might be absent, saying that the class is cover, those things still have to be handled. The show must go on, right? Okay, so that means there's a coordinator. That coordinator will start to prepare the scaffolding. For example, copy the slide template, name it appropriately, assign people to sections, and then get their profile pictures so they can be on each section part. Okay, then the individual lecturers, those are the 5 people who are actually giving the lecture, who make their sectional slides. Again, you may be wondering, do I have to come up with the slides myself? You can. It's a good exercise to do that. You can ask a LLM or VLLM to hallucinate them for you. You can also very helpfully use some of the tutorial slides that have been presented by other people. You watch this, now you have to regurgitate it to class. Okay, but put it in the definitions, the types of issues that we have been discussing in class. Okay, so that's the idea. Whatever you take from the internet, okay, make sure that you have attributed and that it is okay to share. Okay. Many times as a lecturer, especially if you can work at least 1 or 2 hours in 1 week in advance of the lecture, what you can do is get the paper and then write to the authors of the paper that you want to present. Okay. Academics love fan mail, trust me. Okay. So you tell them, I'm taking this course at NUS. I'll be presenting your work. Anything you'd like to know, is there any social media handles you want us to, add you or mention you, okay, and they can get more publicity about their paper. Publicity is a great thing for academics. Despite it being sort of like, okay, academics are boring people, academics is really driven by social networks, okay? So that will help them, help you, okay, which will in turn help us, okay? So all of that is good practice that I will write up for you, and I hope you will follow when you prepare the lectures. Okay. Now lecturing, I've already said a little bit, is that we're using this computer here. Okay. So try as much as possible to use the system that we have here. Okay. It has a pen. You can mark it up so you know how to use Zoom, right? You can just put it annotate, right? Press it or use the mouse to press it, okay? And then you can annotate as appropriate, right? So do that so it's more visual, right? Because if you're watching on the screen, you don't have something moving around. It's very boring to watch. Okay. So if you need practice with it, you can practice a little bit on your own first. If you're comfortable with using it, you can come to this room ahead of time, say an hour before. Let's try out the system so you're comfortable with it. Okay. Knowing some keyboard shortcuts is always very helpful. Like Google's Slides has the laser pointer, it has the arrow, jump to slides, knowing those keyboard shortcuts. Okay. Any questions so far? Okay, you guys are all pretty bored looking, so I'm going to run something which is one of our support things that we do in this class. Okay, so we're gonna play a game. All right, here's the game. Okay, so I think many of us have played this before. So you need to scan the QR code or go to Kahoot.it so we can pretend we're Italian. Okay, and then type in the gate number. Okay, 799-389. Okay, and I'm going to do what I'm going to ask you guys to do when you're the support leader for Kahoot. Okay, so we're going to get. See, we've got about 20 people here, another 10 online. So when we get to about 30 people, we'll start. Okay. So we'll wait for about 2 or 3 more people. About. Oh, yes, okay. All right. Kahoot is meant for fun. It's not meant for anything serious. But the whole point is like the person preparing Kahoot needs to remember what happened in the previous lecture and write between 5 to 7 questions. No more than that, because otherwise we'll play Kahoot the whole time. We won't learn anything. Okay. So I'm going to start Kahoot, and then it's stripped off answering the question. Okay. As the Kahoot leader, our job is to narrate the Kahoot. Okay. So that's very easy. You just read out the question. You can make jokes if you feel like. So I ask you, what gets augmented? Okay, on your phone or desktop, you can answer the question. This down. Okay. Is it a retriever gets augmented? Is it an LLM gets augmented? We augment an electric generator, or do we augment a fusion engine to create an image like the one that shown? Okay. So the answer is an LLM, right? We're doing retrieval augmented generation. We use the retriever to find documents or context or some data, right? Because it doesn't have to be text. It's just some type of data store. That's what we had on the slides, right? And we use that to augment the context that we're going to send like a prompt to an LLM, right? The LLM is going to do something. So the other ones are probably not very useful. You know, the fusion engine to create an image, that might be something possible to do because that's just source implementation. Okay. Very good. We'll go to the next question. Okay, so Manas first place. Hong Shu is in second. Haitao in third place. Okay. And we have a couple people coming up. Our game ID is also coming up. So we go to the next question. The augmentation is done during what? Okay. Is it done during training time? Is it done during development time? Is it done during test time? Is it done during evaluation time? Okay, so you can pick one of them. Then, like this young lady, try to take the test. Okay, so I think all of us are understanding that we usually do the retrieval augmented generation at inference time or test time, right? We're running decoding to try to generate an answer. You already have a pre-trained model, an LLM, right? It's going to get all of these queries from the user, going to go out to the public internet or the data store, or private, retrieve documents or context, put it into the context to create an answer. Okay. So evaluation time isn't strictly wrong. More people will call it test time, or you could also call it inference time. Okay. So again, we're not being very serious with the pointing, otherwise that would also be very concerning. Okay, how are we doing? Okay, Isong has come up in first place. Jiaying, our two people all the way in the back row, are first and second. We have MG, our game ID is still doing pretty well though. Augmentation is only done with autoregressive LLMs, true or false. Don't know what that means? Okay, you can just guess. Right. Here's an autoregression problem, right? The answer is indeed false. You usually right now do it with an autoregressive model. An autoregressive model is again one that uses regression to decide the next token. So it's using what it generates to predict additional generations. Okay, but it doesn't have to work that way. It can work with math language model as well. It's just more sophisticated and maybe more complicated math. So okay, but there are lots of pre-trained models that use some to do this type of augmentation. Okay, great. So Isong is still in the front, Jiaying still in second. Looks like we didn't switch much. Okay. So what is meant by knowledge editing on this slide? So look carefully. This was from our slide deck. There is a little part right here, okay, for knowledge editing. So what? Sorry, right? So what do we mean by knowledge editing? 1 second left. Okay, so I put it at the front because I was writing too much text. So I at least made sure you could read the first answer. See that is correct. When we mean knowledge editing, we mean going back to the trained model, right, and then trying to change the weights. Okay, that is a huge area of research. It's what a lot of people in what's called LLM or foundation model alignment are normally doing. They're fiddling with the weights in the model to get it to say certain things, to get it not to say other things, right? So that is a form of editing, you know, or censorship, whatever you want to call it, basically. Okay, our models come up in first place. I'm very impressed. Okay, Zidane is the highest timer. Not on the leaderboard yet, but going up. Okay, the last question for today: why is RAG possibly a good reason for private data? Because the data store can pull private data, because the similarity to the data store helps create better guardrails for privacy. With LLMs could memorize and recite tokens considered private, or is it because LLMs cannot generate private data? Okay. So this was a little trickier question. There are two right answers. Okay. The data store, when it's drawing from a foundation model, can sometimes show training data, can memorize training data. And some of that training data, if you've been sanitized properly, can contain private information. This is one of the key benefits that people say RAG has, because you can use the foundation model just to learn general knowledge, like how to speak a certain language. And then you can use all the private information that you need. For example, you want to operate on HR documents in the company, you put that in the data store. The LLM can use it to generate answers, but it's only from your data, right? It's just pulling from. Okay, so what I did just now is the narration. You don't have to do it as with or whatever, but you do need to prepare the question. Use ChatGPT, Claude, whatever to help you with that. Okay, find an image that's useful or not. Okay, there are ones that are in this description that you can use to prepare, and then answer the question. So let's thank Jiaying for doing a great job today. 799,389, whoever you are, you did a great job. And Juan in first place with 3,481 points. Okay, so we are doing this every week. Why? Because it is important to connect the last lecture with the current lecture. Okay, so it is already, I don't know what time it is, 20. Okay, so we spent 20 minutes doing that. That's why I said we don't actually have that much time. Okay, with that, I think we should go to lecture, but I would invite all of you, again, to go through the sheet, identify which weeks you are assigned to, go immediately to Slack, add yourself to those channels. Okay. The second thing I will ask you to do is if you have the Drive link in Slack, okay, go again to Slack. Okay, in Slack, we go back. Okay, general channel, which is PR, go to bookmarks, Drive. Okay, from Drive again, just select Scribe, the support roles document, and you can read about the support roles here. I will talk more about these if there's time at lecture. Otherwise, we will discuss it in Slack. Okay, the document isn't finished yet, but we want you to use the support time in a way that helps us do a better job of learning the material. Okay. Okay. So one other thing that's going to happen, Yisong, who's one of our PhDs, he will be doing the discussion catalyst role a little bit later today. So I heralded him just 10 minutes before class. So now he has 4 hours, the next 2 hours of time to come up with some questions for us to discuss. Okay. So what I just did for you was the quiz setter role, okay, where you use the Kahoot account to make MCQ. You can actually get all the MCQs from ChatGPT if you want. Okay, but it's good to put some effort because again, this helps you remember the materials better. You just consign AI all to do it, it will do it, right? But it won't be very fun. And you won't learn anything from the exercise. Okay. So try to make it useful to you. So I'll offer some hard questions, some easy questions, some questions in every section so that we can put stuff. Okay, with that, we're going to go to our first lecture. So again, you can get to it, no surprise, using the same URL, okay? soc.n.us, CS6101, P2510, W01. It is also, unsurprisingly, in our Drive, okay? It's meant to be very easy. So Google Drive will be our learning management, okay? Along with Slack, okay? So you can follow along and then ask questions about that. Okay. So with that, I want to first introduce Prof. Haitao.
Hi, nice to meet you.
So Haitao is a professor at the University of Tsukuba. He's a sabbatical visitor to NUS group. His specialty is information retrieval. My specialty is both IR as well as NLP. So we thought it's good to offer this class. Information retrieval is also taught as a 3,000 level class in SOC, but it teaches more of the traditional information retrieval. So RAG is where these things get put together. So we think it's an awesome time for you to learn RAG for us to get more people interested in that. Haitao, do you want to say any quick words about yourself and your research?
Okay, just a short brief introduction. So, I'm from University School of Accounting. My group focuses mainly on information retrieval. But now we are also studying about multimodal cases. That's okay. Thank you.
Okay. Haitao and I will also serve as discussion catalysts when you guys come up to give lecture. When you give lecture, we ask questions. Don't be intimidated. They're usually just inquisitive. We're not going to keep you on it. Okay. You don't know the answer, just simply say, I don't know, and don't be embarrassed about it. It's perfectly fine. This is a study group. It is not a lecture, believe it or not, even though I am lecturing. Sorry for that. Okay. So with that, I think we'll get started. Okay. So what we're going to do today is go through 4 sections. Haitao section is the longest section on retrieval orchestration, but we've assigned some slides to talk about optimization, which is small part, and also some definition preliminary, and give you some future directions. Now, because this is a course all about the entire RAG pipeline, it will be pretty daunting to make sure you understand everything. Okay, so we're not even going to try. We're going to give you like a 37,000, 40,000 foot overview of what it is. And then over the next 12 weeks or so, we're going to dive deeper. Okay. So when you do your lecture, it's fine to get much more technical than we will. And even if you don't, sometimes we will ask you, oh, let's go look at this paper. Because it's hyperlinked on the slide, we'll ask everyone to go to the paper and we'll be reading the paper together on our laptops or tablets and discussing it. Okay, so again, when we talk about an LLM, right? An LLM is a parametric model. It has a bunch of weights. It has a specific architecture. So these are parametric models, right? But they can generate text conditioned on input that they get. So if you remember last week, I showed you the conditional probability formula where there are a number of variables, usually some type of token embedding, okay, which we condition on to generate, right? So the whole thing when we talk about language models being spectacularly stupid and all they're doing is predicting the next word is pretty much all we're doing. It's the math. Okay. So the formalism is just a condition on some input, x1 through xn minus 1. And we want to figure out what's the next word that we have. Okay, so there are some bottlenecks that are known here. Annotate the slide. So particular. Okay. The prevalence of factual errors, right? So it can get information that's correct. It doesn't usually tell you where it's getting that information from. Okay. It's hard for us to institute certain good guardrails, right? So these are sort of like alignment guardrails. Okay. And then also very expensive, right? Because you have to encode all the previous information and then decode one token at a time. That's usually the auto-progressive nature, right? So that's the expensive part. It's not just the inference, but more the training time, right? So training all these models work. And very large size models, so single lot. Okay. So then to supplement this, we can think about RAG, right? So we covered this last week. And so what it is we're going to take input X. We can call that also our query, right? Query here. Okay. The retriever first retrieves relevant information from an external data source. So we're going to call it a retrieval function, let's say RDT, then they give it the query. And we're also also, sorry. We're also going to give it a data store, right? Which could be, okay, and we're gonna get back a set of comments, right? So we're gonna get whatever retrieve context. Let's call that C0, C1, C10. Okay. And these are going to be added to our context, and then our Retrieval Augmented Generator, our LLM, is going to condition on the query and context, so all that stuff that we just retrieved. Okay, and generate an answer, right? And output Y. Okay, whatever that's going to be, some text or an image or anything, right? So it's just conditional. So you think of this as a conditional power. Okay, so that's pretty simple enough. Okay, so we can just think of it like this, right? We are getting some query from the user. LLM executes a retrieval first to ask about X to the data store. It's going to retrieve some context, which I indicated as C, and then it's going to do this function of generating, right? And the data is the parameter, so this is when we call it a parametric model. So all the weights in the model are data, and then it's going to output this Y. Okay, so that's just a diagram, right? Okay. So the advantages is we can potentially address all of these concerns, right? So let me turn it over to some of you to think about some of these. So what might we say is happening when we deal with something like easy to adapt to new distributions? What do we mean by that? Can anyone help me? This is a discussion, right? What do we mean by like adapting to new distributions?
The new distributions that are, let's say you upload a corpus to the app, and now the distribution of the tokens has changed. So those tokens, along with the current distribution of the data that it has learned, those are now combined to form a new distribution.
Okay. Okay. That's great. That's generally the idea. Can anyone give us an instance of what Pang Mei has said? Like if I have a general language model and I want to, let's say, adapt it to a new distribution, what like concrete new distribution would I care about? Yeah. Your name again?
Yeah, for example, you can retrieve some knowledge that does not exist in the LLM.
Okay.
So there's a new distribution of knowledge.
Okay. Can you give a concrete example in case somebody can't figure out what is a new distribution?
Yeah, like private data you mentioned in the quiz.
Okay, so let's say HR records, bonuses, salaries, addresses, things like that, employee things. So those things we might not expect to have in our general distribution of training data for a foundation model or an LLM, right? In fact, when it's there, it's actually a bad thing, as we showed many slides, because we can retrieve that information that shouldn't be, right? Okay, your name again?
Jindong.
Jindong. Okay, so Jindong says, we can adapt to new distribution. It could be, like private data. Okay. So, those are some of the things that we can. We also talked about number 5. What might we mean by 4 parameter efficient? Somebody else?
Basically, we don't have to retrain the models on the new data. For example, let's say we take an old model which hasn't been trained on latest news sources. We don't need to go over, I need to retrain it, make all the parameters updated, etc.
Okay. So Sahej said, we don't need to update it with new parameters or a new piece of information that we give it, right? You remember from the last lecture, there was one last slide that says we can potentially use a very small LLM. Why? Because maybe we don't want the LLM to know any facts. We just want it to know how to speak English. Okay, that's the thing that we want. All the information that we need, we'll give it in the external data store. So you don't need to encode Wikipedia. You don't need to encode, all the world's knowledge. Okay, we're just going to retrieve that knowledge. But we're going to use the LLM to make it into English text, for example, or a Tamil language, a speech, right? If you're going to realize the multimodally, right? Like there was a couple lectures a couple days ago by people from Google advertising their Gemini model that did code switch into, I think, Indian. Okay, Indian English for answering that question. Okay, but in any case, that's the whole idea, right? You don't need the entire world's knowledge resident in your LLM. You just need one that can generate useful language. Okay, certainly that's a easier one. Okay, so there are a bunch of key references here. So when you come to prepare your lecture with the rest of your lecture group, okay, you can come back to some of these. Some of them we've actually covered last week. So this ACL 2023 was by colleagues from the Princeton and Stanford, UW. Okay, so I thought made this slide is very interesting. Do you think you're doing RAG right now? Okay, so we're giving you facts slides, right? So are you doing augmented generation? All right. What do you guys think? Give me an answer. Yeah, okay.
I don't think exactly in definition because technically our brain is still learning from the slides. So there's some parameter that are being updated.
Okay, so we're doing model training, maybe say that. Yeah.
But something
So
like
maybe-
let's have to call a friend and I just search the number, that's technically like search in the phone directory or something, that's technically a form of RAG as well.
Yeah, so when we look up external sources, right, when we use a service, you can think of any tool use as sort of like retrieval augmented or tool augmented, right? And then the question is about the AG part, right? This part over here, right? So when we do AG, it means we're generating something, right? So you can think of generation in your head, like you have to, consciously think, right? So you're producing tokens in your head right now, right? When you're thinking, okay? So that could be augmented. So you can think right now, even the business of education, you can cast into the framework of RAG if you want to, right? So there's a lot of caveats that Angmei pointed out, but others that we may also. So our goal is again a discussion group, so I can see that people in the front are more willing to contribute. So I hope the cluster of people online, especially. So there are 16 of us online besides myself. Okay, I hope some of you will also be able to ask questions. Okay, just unmute and ask, and then give your opinions. Does anyone have any comments on this? Oh, okay, so okay, so I'm going to stop there and hand it over.
Okay, I will continue with the second tweet, the retrieval orchestration. First, as related this illustration of RAG framework, as we can see, just a number of components, an external data store, a retriever, and the parent. At the first step, it seems very simple, right? Very straightforward. You just combine them, it will work. But unfortunately, it's not that straightforward. In order to achieve effective RAG performance, it's not that straightforward. If they don't think of it, I mean, the entire RAG process. In fact, we have many decisions to make. As we can see, when to retrieve, That means in the context of RAG, not corresponding to each query. It's not a must, right? Sometimes we need to perform to retrieve, but sometimes we better not to in order to improve the efficiency. Next, where to retrieve. That means in reality, we commonly have many candidate resources, maybe web, that's external data store or multimodal data store. Not a number of available resources. Sometimes we have to make a decision which external store we use. Okay, good.
Sorry, you're a bit faint sometimes. I couldn't catch some of it.
Sorry, I didn't hear you.
I was not able to hear you for
Okay,
some of the sentence.
okay, thank you. That's where to retrieve. For the third one, what to retrieve. Here we mean how to formulate the search query. Sometimes the most simple way is to directly use the input as a query. Unfortunately, it's not always work. For the fourth, how to retrieve, it means how to perform retrieval. We need a way of retrieval. It involves the problem of retrieval methods. In fact, we have many candidate retrieval methods, so we have to make a decision. Finally, presentation and consumption, it refers to given the retrieved results, we have to find a reasonable way to provide it to LLMs and determine how to use this retrieval results. So as you can see, it's not that straightforward. We have many things, many issues to cope with. So next, corresponding to each question, double question or whole question. So I will list a number of representative papers. First, we'll go with when to retrieve. Let's have a look at the table on the right side, especially the second and the fourth. We can see that for some input instructions, when we use LLM, it's not always the case we have to retrieve. So it indicates the case we have to make the decision when to retrieve. So in the ideal case, we prefer adaptive retrieval. That means adaptively performing retrieval. Invoke the retrieval path only when the LLM needs external information or knowledge. So for this subtopic, in fact, there are already many papers. We can classify them into three categories, such as the classifier-based methods. It means that for the input query, we first train a number of classifiers, which help us to make a decision. Okay, for this kind of query, we'll perform retrieval. Okay, for another kind of query, we'll not perform retrieval. So that's a very straightforward idea. It uses classifiers to make the decision. The second category is called competence-based methods. So for this kind of methods, it means that it will develop a method, commonly a kind of threshold-based method, to make the decision whether to perform retrieval or not. For the third category, LLM-based methods, it refers to the case making the retrieval decision is made by LLM itself. For example, by predicting some tokens, search, or provide the answer like that, using LLM itself. So for these three categories, we listed a number of reference papers at the bottom. Please take them as a reference. Next, I will introduce a little bit more about one example paper. As shown at the bottom, unified active retrieval for retrieval augmented generation. So let's have a look at the figure on the right hand side. Within this work, the authors propose that, I mean, they propose 4 category, 4 orthogonal criteria for determining retrieval habit. For example, the intent aware, knowledge aware, and sensitive aware, self-aware. Here, let's take the intent aware as an example. It means whether the user is there as retrieval or external information. So according to these 4 criteria, the authors, in fact, trained specific classifiers based according to these criteria. So given the input query, these as shown on the left-hand side, as we can see, it's a kind of decision tree, right? I mean, the classifier will be, activities based on the decision of the or based on the output of the classifier. Each determines whether to perform retrieval or not. So the idea is very straightforward, not that hard. Okay. For the second question, where to retrieve? As we mentioned, in the case of when there are multiple available external data sources, so we have to make a decision which data source to use. So in this context, there will be a number of challenges, such as the cross-source duplication and conflict resolution. That's one potential challenge. The second one is source selection accuracy. That means selecting the most reasonable source view. The second potential challenge is heterogeneous data integration. So these are quite challenging issues when we solve the problem of where to retrieve. Meantime, we also listed a number of reference papers that can be used as a reference to cope with this problem.
But before going on, does everyone understand what all these 3 bullet points mean? I think it's good to try to clarify.
Maybe you can explain more about the bottom two, the source selection and the heterogeneous data distribution.
Okay, that's good. So can we collectively as a class think about what would it mean to be selecting a source selection accuracy? What might that mean?
So probably some source is more reliable than others. So you would prefer the more reliable source.
Okay. So that's the case where we can say there's some confidence with certain things. So to make it concrete, we would say maybe Wikipedia, when it was first started, nobody wanted to use that as a source, but now everyone refers to it as sort of the source of choice, right? So when you think about something like Baidu or Google ranking, right, we prefer things top to the top of the list, right? Is that the correct interpretation of source selection accuracy?
Yes.
Okay.
That's correct. You see, there can be SQL databases, right? To provide some additional information, there can be Wikipedia or information crawled from the web. Kind of resources.
Is there some algorithm like a Google or PageRank or something like this? Put it here, or it's totally different algorithm.
You mean the algorithm for
solving, yeah, because like a Google, right, which one is first, which one is the algorithm sort that, rank that, right? Is that a similar or is it very different here?
So I think for the picture based data, it's just a part of an external source. There can be other kind of resources. Because maybe some companies data or transactional data.
Yeah, could be SQL. Yeah, sure. I guess my question is how the algorithm know which one is better. Yeah. How they rank the source.
So for this question, it depends on the input variable. Yeah. It depends on the input variable. Namely, what kind of question will be asked.
So I mean, IR in general, like you said, you're Jonathan, right?
Yeah.
So Jonathan mentioned PageRank. Are we all sort of familiar with PageRank? So PageRank is an algorithm that basically looks at the importance of the incoming hyperlinks to a page and uses that to rank whether a page is more important than another. So you can use, for example, the number of hyperlinks coming into a page, but then you can also make spam farms where a lot of pages that are useless point to a single page. So it has to be based on some type of recursive definition of prestige.
Yeah.
So you're only important if other important pages point. So that's the idea behind PageRank. That's where PageRank is actually named after Larry Page. Under Google, it has nothing to do with web page, although that's a common misconception, right? But like Haitao said, Google uses that as one of I think 300 or 400 different signals that it uses to rank. So there's a lot of different things that you can use to rank. And I think the point here is it depends on the query, depends on the context, right? So if I ask a query like where should I go eat, and you ask it, but at a different time in a different location, the answer should be different. So all these types of things influence the ranking, and it depends a lot on the question trends, right? Like some of the ones that we saw in the earlier paper, they're time sensitive, so you need to consult time-aware sources in certain cases, and some that are not, right? So that you wouldn't use time as a marker of indicating what is the correct answer or correct page at time. Other questions?
Hello, Professor. Can you hear me?
Yes, we can hear you. Please go ahead.
Yeah, I'm an online guest, and actually, I'm having a problem about. Could you please turn to the previous page? That's the. Yeah, yeah. Actually, I'm a little bit confused about the figure on the right of the screen. You can see that there are 4 different MLPs. Are they indicating some sort of like MOE structure or something else, since we know that in regular transformers, it only have a single MLP?
I think you're referring to the set that's in the middle, right? Under the AI assistant, is that right? Yeah. So there are 4 different MLPs there. They're all tunable. That's why there's the flyer there. So I think what they're indicating is it's correlated to the decision makers on the right-hand side, right? So if you look at the decision tree on the right-hand side, they're colored the same as in the left-hand side diagram, right?
Oh, I see. So actually, they are some external model structures, not the structures from the original model. Yes.
Yeah, my guess is, each of these MLPs is trying to make a binary decision, right? So the first one, I think is intent aware, right? Classifier.
Yeah.
So based on its training data, it's trying to decide whether you need external information or you need to retrieve, right? So if the classifier says, yes, you need to retrieve, then you do something like RAG, right? If you don't need to retrieve, then we pass the information onto a second model, the second parameterized model that makes the decision, right? Based on, let's see, what does it say? It's knowledge aware, right? So whether it needs factual knowledge or not. So if it needs
Oh.
factual knowledge, it'll go to the first one. If not, it will go, and not do retrieval, right? It'll just go and generate. Does that make sense?
Yeah, I see. So actually, at the very beginning, I was thinking that those MLPs are external structures. And what I mean by it is confusing is that you can see that in the left part of the figure, it seems that the four MLPs are performing some sort of computation in parallel, but in the right part of the image, you can see that it's like a decision tree or something else. Is that one performs the decision and it handle it to another, and so I think that it's creating a little bit sort of confliction, which makes me not so confident about that the four MLPs are actually, but I suddenly found that the color is corresponding. Yeah.
How do you know?
Okay, I think the question is, okay, on the left, I mean, the four MLP modules are in parallel. On the right hand side, it's a kind of stack. I mean, binary decision one by one. Do you mean that?
Yeah.
Okay, so we can, based on my understanding, when I read the paper, so first the four classifiers are binary classifiers. They are used one by one. So maybe the figure on the left is a bit ambiguous. So you can
I
put
see.
permits based on it.
Yeah, I see.
Okay,
Okay, thank
on
you.
the
Thank you
general
so much.
channel, I also pasted some text from the actual paper. I went and put the hyperlink and I went to the paper to read. And it does say, as shown in figure 2, we fix the parameters of the LLM and treat a lightweight classifier for each active retrieval criteria using the model's hidden states. Okay, so that's what it's doing in that middle layer where all the fire is indicated. So it's in the general channel on the slab. Okay, so what I see is that at training time, it's training all four of these classifiers. Okay, and then at test time, it's actually, maybe computing the output of these four classifiers in parallel, but it's using them more in the decision tree, more on like the right-hand side.
See.
But how did they decide that, okay, we'll ask the intent aware classifier first, then move on to knowledge aware, then time sensitive?
That's a great question. I'm not sure that they say exactly how. I think
Yeah, my question was that how did they decide that they'll ask the intent aware classifier first, then the knowledge aware, then the time sense? Like, how did they come up with this specific sequence? Why not knowledge aware first?
Maybe it doesn't matter. Maybe you can just stack in whatever and it'll still work. Think so?
it could be.
I mean, if you look based on the diagram, if it doesn't hit one, you'll hit the other one eventually. It's more of like if it at least hits one criteria, it goes anyways.
Yeah.
So perhaps it doesn't matter. I feel like it would matter if, let's say, there's one classifier that is like more likely to hit, then you don't want to waste your time. I guess that might be more useful. But in a sense, if it's hitting, if you just want to check for one hit, then it doesn't matter which one hits first.
Yeah.
Point. Case-wise at least.
So for this question, I mean, the order does not matter, but it affects the efficiency. You see, I mean, given these four criteria, in order to make like, if you want to improve the efficiency, that means you have to understand the visual carriage corresponding to each picture. Okay, for a specific kind of query, if it takes up a high visual, that means we have that kind of primary classification first. In that case, it affects the efficiency. For the final result, it should be the same, like we perform like decision tree. That's my answer. Thank you.
Yeah, I also pasted from their paper. They say they run multiple retrieval criteria and unify them into a single decision tree. They don't specify how they came up with the tree. Yes.
Don't how we classify it, so why do we not customize classify first, so we base that on.
Yeah, these classifiers I think are pretty small. If there's normal machine learning based classifiers, like a linear regression model or even a decision tree, they should be pretty fast to run. Right? They're not, I mean, MLPs, they could be as big as a large language model, but I think they probably take simple classifiers.
It could be a small model in the case of efficient.
Online, does that answer your question? Sorry, we can't see who you are, so we can't see whether you're satisfied with the answer or not.
Yeah, I'm satisfied about what is going on in the discussion.
Okay, that's for your question. We'll double check it, please. Yeah. Okay, because we're continuing. Okay, I know, I mean, we talked about where to retrieve in the context of multiple external resources and the potential challenges. For the next subtopic, it's what to retrieve. Here, we mean how to formulate effective search queries. So, as we mentioned, the most simple case is we directly use the user input as the search query. But in some cases, it does not work because sometimes the input user query might be ambiguous or might be quite long, right? So we have to solve it. So to cope with this kind of issues, there are a number of strategies such as compression. That means given the long input search queries, we will have to compress it into short queries. For experiment, that means sometimes the input search query may link some information. We have to further expand user query in order to make it clear we understand the underlying user intent. For the search converted, it means sometimes we have to reshape the input into a new query in order to make it more clear. For the post decomposition, it means sometimes we have to break down a complex input into a number of simpler parts in order to better understand the content and retrieve more accurate results. So why not? We listed 4 specific strategies. If we recall the previous paper we introduced, given a large number of queries, but sometimes a specific query works for some queries, right? So overall, we prefer an adaptive query formation. Let's watch the red content, adaptive query reformulation. It means adaptive formulating the search query is preferred. Again, I mean, at the bottom, we listed a number of papers. You can use it as a reference to have a good understanding about what to retrieve, namely formulating effective queries. Next, we'll introduce an example work about adaptive query reformulation. As we can see from the figure, on the left hand side, there are 4 queries. In fact, given these 4 queries, they correspond to different types of queries. For example, for query 1, in fact, we can directly provide the answer. For query 2, the chain of thought strictly is a better choice. For query 3, we have to regress the query in order to get relevant information. So, as it shows, what it indicates is that given a large number of queries for different queries, we better make an adaptive decision with respect to different query types. So if you are interested in this work, you can take the bottom paper as a reference and for the details. Of course, if you have some comments, you can ask. If you are curious about something. Okay, please, somebody.
But this isn't specific to just RAGs, right? This can be done for like your LLMs itself. Because this one is specifically for like, the query. So effectively, you're just changing the query to be worded better so that you can retrieve better. Is it more for the retrieval part, or is this like can be used for just basic like LLMs? Because based on this, like the adding COT things similar to just like LLMs without RAG.
For this, like the proposed method shows, it's called query root. That means before retrieval, we have to make the decision to formulate an effective search query before performing retrieval.
Right, so if you look at the middle yellow and the bottom green one, those are the parts where it is going to RAG, right? Yeah, but you're right to say the orange line when we say add COT, it is more like a generalized router, right? So the router is deciding, okay, when I look at this query, like query number 2, right? A cage contains 4 animals, 10 legs, count the chickens and rabbits. Then the query router is like, oh, those types of queries I've seen before, they usually require me to decompose the problem into multiple steps. That probably requires COT. So I'm going to do COT, right? I'm going to do chain of thought, right? But there's other cases where like number 3 and number 4, right? Where they're saying, oh, well, actually, I need to do certain things. I need to retrieve the query because like the way that the query was written in number 3 is not very good. I want to rewrite it in a way that I think I'll be able to retrieve an answer.
So it's something like, so it also helps to solve the issue of like when to retrieve as well in this particular.
Yeah, I think it's not just the thing to say just what to retrieve, but yeah, many of the papers they don't just answer one WH question, right? They might answer more than one. Yeah.
Would this mean that the classifiers that we saw previously, that would be part of the query accuracy or like later on?
Yeah, I think they could be. I mean, what to retrieve and what was the other one called? Get already. Yeah, when to retrieve, right?
Yeah.
So yeah, they're similar in nature. Yeah. So I guess the when to retrieve part is talking a little bit about efficiency, right? So if you don't need to do the retrieval, or you don't need to or you need to know to do the retrieval, it's helpful to know that early on, right? There's also a question online from MyBot.
Yeah. So I would just want to ask that what kind of model are we using in query router, like any particular model they have mentioned in the paper, if you know.
So what type of query is being used? What model is being used in that paper?
Yeah.
Okay, we can go to the paper and take a look what they said. Does anyone know?
Yes, you can take the link. As far as I can remember, I think it's a pre-trained. They have to prepare some training data to personal fine-tuning.
Yeah, okay, it does say so. On page 6 of the paper, if you look at 4.3, I'll just paste the image of that part of the paper. In general. They do say that they're using BERT. So BERT is a rather small these days, 110 million parameter. Pre-trained on, like Haitao said, on the squad and blue data sets. These are mostly question answering and blue is a fairly large benchmark for a lot of different tasks as the base model for their query router. Right, so they're basically taking all of these tasks and saying, you know, which of them need a direct answer, which of them need, you know, chain of thought, which one needs to be query rewritten, which ones need to be query expansion. Right. So contrast that to the first paper which we talked about, which was more about when to retrieve. So these are more like, tell me what I need to do, right? That one is tell me the descriptive nature of the query, right? So it's a little bit different. This is more, tell me what operations I need to do right now. Right? So it's more prescriptive. That one was more descriptive.
Yeah, for this question, it means, I'd like to note that, for example, when to retrieve, it's determined whether to perform retrieval. For this part, what to retrieve, okay, if we perform retrieval, how to formulate the search query, so like a sequential. Yeah. Like that. By the way, I'd like to note that even though right now we are introducing the papers by this kind of categorization, in fact, some of them can be explored jointly. Okay, let's continue. Next, about voice retrieval, I'd like to emphasize another book. In fact, it's a very detailed read. Within this work, it talks about the concept. It's called query stratification. So as we can see from the figure, they classified the input query into 4 levels, such as explicit facts, implicit facts, interpretable relation, rationale, hidden rationale. So here, I just mentioned that because of time. So if you are interested in it, so please I'll look at the details. In fact, within this work, corresponding to each level of input queries, they listed and they detailed corresponding representative works. Because we have more content in the text. So another work I'd like to mention about what to retrieve is called query routing. Here, query routing is different from the previous section. In the previous section, when we talk about graph, okay, it's just one LLM. Within this work, it refers to the case where there are multiple LLMs That means for the input query, given multiple LLM, sometimes we have to select the most reasonable one to use. As we can see from the example on the right-hand side, for Llama and Tianwen models, sometimes, in some cases, if they perform retrieval augmentation, it becomes unanswerable for some model. But for another one, I mean, for the same but query, for one model, if we perform retrieval augmented generation, it becomes unanswerable. But for another one, it's answerable. From unanswerable to answerable. So that means the selection of LLM is also matter. So here, this pair routing refers to this case. Given multiple how to select the most reasonable one to solve the problem. Next, we'll talk about the subtopic called how to retrieve. Here, it's mainly about the selection of the retrieval method. As you can see from this three paper, this is at the bottom. When we talk about the retrieval method or the retrieval model architecture, in fact, it has a long history because in the field of information retrieval, it has been it's not several years, 30 or around 40 years. So of course, the evolution of model architectures, yes, as you can see, there are many groups of models. So if you are a beginner of information retrieval, you may get lost. In our case, we'll introduce a number of groups, especially the representative retrieval methods. So here, about the detailed evolution of model architecture, please refer to this study for details. The first representative category of retrieval method is called sparse retrieval. As the name shows, it means for queries and documents, we represent them with big-dimensional sparse vectors, which includes a lot of non-zero elements. Maybe some of you are familiar with the listed models, such as the very traditional TF-IDF, TF-25. They are also sparse retrieval methods. For the later category, like neural-based sparse retrieval, maybe some of you are familiar with them, like ST plates or deep impact. These are neural sparse retrieval methods. So for this kind of retrieval method, the benefits or the advantages are that they are efficient based on the structure of inverted index and has a strong ability of term filtering. These are the advantages. So if you want to get a better understanding about sparse retrieval at the bottom, as you can see, the tutorial given at SIGIR 2025. Please take it as a reference. Next, we'll talk about the category of retrieval method. It's called dense retrieval. As the name shows, dense retrieval means we represent either query or documents with dense vectors. We can further differentiate the methods within this category into single vector retrieval and multi-vector retrieval. Here, for single vector retrieval, we represent both query and documents with a single dense vector. For the multi-vector case, the unit of vector is not query and document it's a turtle level. As we know, for both queries and documents, they consist of multiple or many turtles. So that's what multi-vector retrieval means. If we have a look at figure in the middle. For the previous two figures, namely A for A and B, they are mature methods. Within the era of pre-birth, I mean before birth, when we use neural networks, they are like this. I mean, the input will be based on like word to vec or doc to vec to embed every documents and finally compute the similarity. So for the third one, or the figure C, it's a word-based retrieval method. As we can see from here, for the input pair and documents, I mean, using the pair and document and input, it will be a kind of out-of effect within the attention mechanism. I mean, the inner structure, finally, the token like CLS. The vector corresponding to the CLS token will be used to predict the similarity between the input pair and document. These three, I mean, they are single vector retrieval method. For figure D, a technical method is called covert. It's a kind of latent vector. And we can see from the figure, given the input pair and document, right? We first use the encoder to encode them independently. Finally, I mean, given the input pair and document, we compute the similarity based on the token level vectors. For example, for query, it consists of a number of tokens. Each token will correspond to a vector. So the similarity between pair and document, as we can see, there is an operation called max sum. Within query, there are multiple tokens. Within documents, there will be multiple tokens. The max sum operation will be used. And finally, there will be the sum operation against the similarity between pair and documents. So these are four representative structures. Next, we can have a simple comparison. As we can see, for the single vector case and the multi-vector case, if we make a comparison based on the properties like the representation, for the single vector case, that for a query will be one vector, but for the multi-vector case, we can see it's 33. That means because the unit is a token, not a single pair. As a result, I mean, as you can see, I mean, the embedding index set, it becomes quite large. So this is the storage is for the latency or mean response time. As we can see, for the multi-vector case, the latency or the mean response time, it becomes higher. On the right-hand side, if you have a look at the performance in terms of either MDCT or MRR, we can see for the multi-vector retrieval methods like covert, it has a better performance. So sometimes we have to make a balance and make a choice according to our real need. Maybe at the same time, someone will think like that. For this method for multi-vector case, latency for the cost is quite high, but don't worry. So here I listed a paper published in 2025. In fact, it's the best paper. It goes the best paper was. As we can see on the right, so the proposed method greatly it decreases, improves efficiency, decreases the running time. At the same time, for dense vector-based retrieval, we also listed severity. You can more detail based on that. Okay, right now, any questions or comments? Right now, we introduce the retrieval methods like sparse retrieval, dense retrieval. If you have some questions, it's either on-site or online.
Okay, does everyone know the difference between sparse and dense or vectors? So I'd like somebody to try to explain for those of us who are unwilling to say that we don't know. Indra?
So sparse vector would be where there are very few ones in the very long vector, and a dense vector would be there's a lot of numbers of a lot of ones, non-zero values, just what you're saying.
Okay, so if you recall or if you haven't learned, again, a sparse vector, we usually use that for each dimension in the vector. It represents a specific vocabulary word. So that means when we represent a document, then it would have ones in positions where there are the words in the passage or the query, for instance. Okay, and zeros everywhere else. So they're usually considered very low dense information because you only have one bit of information position, right? You compress that, you get a dense vector. A dense vector, like it says on the slide there, on the top line, it's a d-dimensional vector, right? So d is usually a small number, usually less than 1,000, something like that. Okay, where we take the entire vocabulary of all possible tokens and compress it to that amount of vectors, right? Amount of dimensions, right? So a couple hundred dimensions to represent all possible meanings that we can input, right? So that's one part. So sparse and dense have various properties among them. And are we clear about what a single vector retrieval and multi-vector retrieval means? No? Okay. So can somebody who understands it help us understand? I'd like to get some opinions. It's fine if you don't know. It's fine if you give a wrong answer and you can just say, oh, I was hallucinating. It's fine. Yeah.
Is multi-vector retrieval like a vector per token in the query?
Exactly. So I think there was like that on the slide, right? We take each token that is part of the query or the document, and we represent that as a single vector, right? And the a single vector is when we push all of that information into a single vector, right? So instead of having a vector for every token, and then considering the entire set of tokens, an entire collection, a whole bunch of refrigerator magnets, each one a vector, right? You're compressing that to a single word, right? Or a single vector. So what do we think are good things about single vector retrieval and multi-vector retrieval?
Single vector retrieval is much faster.
Why would single vector retrieval
because you just have to calculate the thing for one vector. So if I have a huge paragraph, I have to do the math for each and every vector, each and every token, which is going to be very time consuming and will require more computational resources. Like there was something in the last slide, there was a table, right? So the multi-vector retrieval is about 3x slower than the single vector.
So you can see that from the red rectangle, the bottom part, right? It says 630 milliseconds to retrieve lots of results because you have 32 vectors to look up, whereas in the left-hand side, there's a single vector retrieval where the entire query has been converted into a single vector for retrieval. So I think that's what you're. So why if it's so good to do single vector, why would we want to do multi-vector? I mean, there's a case in point here, right?
It's more
Sorry?
for increased accuracy.
For increased accuracy, right? If you look at the right-hand side, which Haitao was just narrating, right? All of these metrics, so MAP, NDCG at 10, MRI at 10, you don't need to know what they mean. We can explain them to you, you can look them up. But basically, higher is better, right? So all these fractional scores go from 0 to 1. You can see they're much better. And Colbert is the right-hand side of the left-hand side table. So even though it's slower, it's getting much more accurate results. So why is that? You can think about it, right? If you're using a single vector, you have to cram all the information about whatever you're asking into a single representation, right? So that, of course, is going to be lossy, right? You can't represent everything very well, right? The standard way that you would do it if you were naive is like, oh, I have a whole bunch of token embeddings, which are all vectors. So I'm just going to average all of them, right? Take all the n vectors, average them all, and then get an e vector out, right? But of course, that doesn't make a lot of sense because we have some words in English and every other language which have more information content than others, right? So you tell me the word does just as important as retrieval. I beg to differ, right? We all know that you know, more common words are have less information content for the most part. Okay, so there's that's one of the findings I think from this paper. But again, we're giving really the top level overview, right? So there's a lot of detail underneath, glossing over, you know, 95% of that, so that we can just give you a very high level idea of RAG right now.
Yeah, you mentioned like the sparse vectors are like basically like one-hot encodings which are compressing to the v-dimensional speed. But like, how does this compression differ from what's like how the dense vectors are being compressed into the embedding?
Yeah, and there are lots of ways to get a dense vector. So if you use standard old style, I guess classical style embedding method like word2vec and Bluff, you get that from contextual representation. So we can go over that in the fundamentals of LLM. I know some of you online are debating what to do for next week's class, right? So we can cover a little bit of that as well. But there are lots of ways you can do, you know, anytime you want to take multiple things and make a single thing out of that, averaging is another technique, right? You can also use dimensionality reduction in some ways, you can run PCA or something like that. Other ways.
Yeah, there are multiple ways. Here's the best thing. And there's a traditional neural network is for birds, like the preferred method, you can use like we introduced here. And you can use a text variable document text as the input, and finally corresponding the CRS token to repeat the corresponding vector representation. That's also another thing.
Okay, other questions? How about you guys online? You guys still following? Anyone else in the room want to ask? Analyze the discussion. Yusuf has been busy putting questions on the general channels. Look at those as well. If your mind's not totally melted yet.
Okay, if not, we'll continue with another technique is called redirecting. So here, redirecting would mean that it will be a pipeline or a multi-stage retrieval. That means for the first stage, we use some very efficient retrieval methods like BM25, where we perform the initial retrieval. Based on that, we use the top 1,000 results to further rewrite them. That's the second stage. For the second stage, we'll use a strong model. Because for the initial retrieval, we focus on efficiency. perform the initial filter. Because the candidate documents or the corpus is very large, right? So that's the objective of the first stage. For the second stage, we use a strong one to further differentiate relevant or non-relevant documents. So in this case, because the size of candidate documents is small, like 100 or 1000, so we can use a strong ranking method like pretrained model-based method or large language model-based method to re-rank them. So that's there will be a trade-off between efficiency and effectiveness. So, here for ranking, we'd like to emphasize the recent work. That means using large language models to perform ranking. Here, within the figure, we showed a number of cases using large language models to perform the ranking. Commonly, it will be the zero-shot case, like prompt-based ranking methods. Let's take figure 8 as an example. We can see we input the candidate passage or the candidate document and the query. We ask within the prompt, does the passage answer query? Please enter yes or no. So it's a kind of point-wise prevention. So for the next case, figure C, instead of inputting one document or one passage, we input two passages, and then we ask the LLM whether passage A or passage B. That means whether passage A is more relevant than passage B or not. The pairwise, right? So for figure B, this time we input all the candidates passages, maybe 10 or 100. We ask the LLM to output the others directly. So we call it a list rank. That's the point-wise error list-wise re-ranking. In fact, recently there is a new method called set-wise. That means we input all the messages, all the documents. We ask the LLM to output the asset label of the most relevant asset. So it's a number of technical re-ranking measure based on LLM. So for more details, then the tutorial given at CGR 2025 also upload reference. So because of time, we'll continue the next one, which is also very interesting. It's called generative retrievals. Here, at generative, we mean that you see, right now, when we talk about the retrieval framework, it's a kind of multi-stage retrieval pipeline as shown in this figure. Figure 8. Retrieval rank. That means given the corpus or the data collection, we perform indexing. That means we construct the index first. Given the constructed index, and we perform retrieval. That means for query, we retrieve from the index and we rank and provide the results. So different from this traditional multi-stage pipeline framework, the generative retrieval framework is like this. We use one model. Really, we can call it a large model. So right now, there is no explicit indexing state. So when we learn the model, it will be we learn the mapping between query and the candidate results. When we use it to perform inference, that means when we perform the retrieval, even an input query, we directly generate the corresponding document ID. So for the learning process, it's a kind of learning the mapping between the query and the document ID. After that, when we perform retrieval, it counts for an input query based on the learned model, it maps to the corresponding relevant document ID. Once we got the ID, we know the document. So this is what the generative retrieval means. So it's another new topic. So for more details, there are some reference papers.
Go ahead, Tommy.
So this model is being run like every time a user types in a query, or only when we are uploading documents to the storage?
Sorry, you mentioned two cases. One is uploading the document to the storage, another is
Sending a query to the main model.
sorry, I don't understand what you mean for these two cases.
It's like the model that generates the IDs, when is it being run actually?
Yes. For generating the ID, it means the retrieval is okay. For example, you input a query for this model, for a generative model to generate the document ID which are relevant, and based on the ID, that's a generative behavior.
That's a great question. It's like every time I have a question, you go to the model will give you a set of identifiers which corresponds to IDs, right? So it's like you go to your library, you say, I want to learn about, I don't know, automobiles in the 1950s. In the library, it says, oh, that's call number, blah, 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 right? So those are the documents. Magme was asking, what happens if we get a new document, right? So let's say the library now receives a big shipments of books from 2025, right? And what do we do with that? Well, then we have to learn a new model, right? Because we have to be able to assign those new books, those new documents to queries, right? So we need to say that when a new query comes in, I have new documents, now I need to know whether those documents are in fact relevant to those queries, right?
Yes, that's a very good question. It refers to the incremental case. Well, there are some new documents, how to update the model. Yeah. There are already some papers. Anyway, it's possible to incrementally update model. Here, we also listed some current experiment results to indicate the differences between the traditional retrieval method and the generative retrieval method. Here, as the figure shows, for this blue and red line, which refers to the methods called AVG in AVG, I think 2025 paper, and another method we are currently exploring. This four line, they correspond to the traditional retrieval method. For the figure on the left-hand side, we want to show the efficiency. As we can see, with the increase of the buffers, for the generative retrieval method, it's a constant response time. But for the traditional retrieval methods, the efficiency decrease a lot. I mean, quick. But on the right-hand side, we can see, well, the generative retrieval method compared with the traditional retrieval methods, the performance is not that competitive with, right? You can see the top performance is achieved by the traditional retrieval method, but it's a high the efficiency with a low. Here, I mean, have a good understanding of these two types or two paradigms of retrieval method. A quiz or question is like this. For RAG, you see, our assumption is that using a single parametric LLM is, I mean, commonly there will be a number of bottlenecks as listed before, right? So it advocates the usage of Retrieval Augmented Large Language Model. But for generative information retrieval, as the figure shows, we aim to use a single model to solve all the steps indexing ranking. So there might be a question whether these two ideas are contradictory or not. So that's a question to think about. An explanation that because of time will continue. So for the final subtopic, it's called presentation and consumption. So for presentation, it means how to provide the results for consumption. For consumption, it means how to use the retrieved information for LLM. In fact, we can further differentiate method into many sub-categories. So this time we will not cover the we listed a reference work, so please refer to it for details.
There's a question online from Vaibhav.
Hey, so I want to talk about the generative retrieval model. So, like initially in the class, we were discussing that the one of the key advantage of using RAG is that we don't need a very big LLM to use it, as we can always rely on external information. But if we are going towards generative retrieval, information retrieval, then the model is only going to get bigger and bigger. So I don't understand like the actual advantage it is having over RAG.
Okay, that's a great point. I mean, this is a point I think we should all try to reflect on. You know, whether it's a good idea to have RAG and whether it's a good idea to do generative information retrieval, where does one start where the other ends, right? Like you can do it all using an LLM only, or you can do everything using the information retrieval paradigm, which is like Google's old paradigm. It's just fetch documents and show them how to use it, right? So now we have hybrids, right? These are both hybrids where generative information retrieval is trying to memorize everything into a language model, right? So Vaibhav was basically saying then we really need one language model or something that's able to generate every piece of information, right? You guys have any comments?
Yeah.
So that is one way you can realize that, right? You can say generative information retrieval is indeed, you know, where we want to actually generate the information to be retrieved, and then we use that for RAG. And in fact, there's a gentleman in my research group, Tong Yao, who was working on this, who showed that there is work that if you ask a person, or in this case, the language model, to recite information that it's memorized, it can do a better job of answering some questions. Okay, so you can think of it, sometimes you need information from the middle of a passage, or like say you're trying to remember the lyrics of the song, but you can't remember the middle of the lyrics. Then you have to start from like some part that you remember, right? You start from the beginning of the chorus, you recite the chorus, and then you come to the part that has the information you need to answer the question, right? So that's the idea behind that. Okay, so generative information retrieval is very interesting because we're asking the language model to use the fact that it can memorize information, right? And use that to retrieve information, right? Because we do it all the time, like try to remember things that we've heard or quotes that we've heard. And we're actually retrieving from memory. We're not trying to use our generative capability to produce new language, right? But generally, we find that as humans difficult, and I'm not trying to anthropomorphize language models, but they also find it a little difficult because the math doesn't work out that we recall exactly what tokens follow which ones, right? We have a generalized understanding of that. So that's a really great question by Bob. So there's no, I think, right answer right now. We would ask you to think about both projects and within the lecture series for you to think about how this comes out, right? Whether you think there's a strong need for generative information retrieval, or we really do need retrieval augmented generation, where we're retrieving from data stores that have certifiably correct, authoritative information.
Yes, it's an open question. Okay,
questions? Okay. Okay.
And Professor, can I ask some following question?
Yes.
Mentioned in earlier. I'm asking that I have some doubt about the core advantage of lag. As you mentioned earlier, lag need less parameter. That is because they can save the most of the knowledge in the data store. But I think when we save more and more data in the data store, LLM would meet more diverse and unfamiliar information when they use that data store. So I think in this case, lag need more bigger LLM which can generalize more diverse information, I think. Isn't it?
So you're saying that when we shrink the language model too much, then what happens?
When we scale the data store more larger, LLM would meet more unfamiliar and diverse information when they use that. So it needs more generalization performance to handle them, I think.
Right.
So
if the collection of documents or things that you want to answer gets larger, you need to grow the language model as well as the RAG. Is that what you're asking?
Yeah, that's right.
Yeah. So I'm not sure. I guess Haitao, do you have any answer to that?
So I think, this is still an open question, like whether you will use run or increase your LLM. I think both could work. Like you should make a choice. Like when your collection or data store increases, I think run always works. That's if you choose some information from use it as an external data source. Of course, you can also, refine your large language model. That's also possible. So that's my answer. I don't know whether you're satisfied.
Yeah, I said I wasn't going to anthropomorphize anymore, but I will one more time. So if you have too small a language model, you can think of it like a baby, right? So their parameters are not very well set. They haven't seen a lot of vocabulary. So you can say like a baby wanders into the adult section of the library. Can they use that to answer questions? The answer is probably not very well, right? So you sort of need a mature mind that's exposed to lots of general vocabulary to make use of information in a very large data store, which in this case, the analogy is the library, right? The library has a lot of knowledge. They're all externalized. And we as adult humans are walking around in it. We pretend we're a large language model, right? So you can't ask primary 2 child or 1 child to go into the adult library and answer questions, right? That would be akin to using a tiny language model and using a huge data set, right? So you're probably right in the sense that you need at least some general language competencies to handle all the different vocabulary that you're going to see, so that the distributional differences between what you're seeing in the data store and what you're seeing in the language model can sort of coincide.
Okay. Basically, I mean, that's all for second. Next, let's back up to. See, okay.
So like Haitao said, in the interest of time, we don't have enough time to go over everything. So we could manage our time better today too. There are lots of papers that got out today. So again, we encourage you guys, especially those in week 2, stay a little bit after class. I will try to go over the process. Okay, but I'll just go through a couple of things for section 3. But I think we'll leave section 4 out, and you guys look at the slides, ask questions. Okay, so we can get out roughly on time. Okay, if we have 4 minutes left. Okay, so this will be the general idea is like, okay, when we have a model, we have both the retrieval model and the generator model, right? Which is in our case a language model. So either one of those can be a frozen off-the-shelf model, which we're not modifying. Okay, but we can also do modification by training or post-training, fine-tuning a model to take advantage of that. So the first idea is, of course, you have a off-the-shelf retriever. So you can think of, let's say, using an API call to Bing or Google, right? So it's frozen, you don't have any control over it, right? But you want to use your LLM, your generator, to do a better job, right? So that's one possibility, right? The second possibility is then to optimize the retrieval. So if you don't have access to changing the language model, right, because you're just using Llama 3, for instance, and you're not fine-tuning it, then you might want to play around. The final one is also possible, right? The final one is to say we're going to do joint optimization of both the retriever and the generator both at once, right? So in the retriever, okay, I'm gonna reload the slides for a second. So in the retriever model, when it's frozen, what can we do? Well, then we have to play around with this generator. So what we can do is we can ask a question, right? And then go using a off-the-shelf frozen retriever, let's say Google, and ask it to retrieve a bunch of documents, right? Or passages, right? And then we can feed those into the generative model and then output an answer. So one possibility is something like this, where we take the question that's asked, and then we use the retriever to get out number of passages here, right? And then we concatenate the question and the passage and give it to a generator. Okay, the generator is going to encode them into a set of tokens. Okay, and then we take these set of tokens and concatenate it together. Okay, and then we decode an answer. So here the generator consists of an encoder and decoder model, right? So we can use, let's say, T5 or some other transformer-based architecture to first encode the question, the passage, the question in the passage, to get out an encoding representing this particular information. So, for example, we could say, again, at the beginning here, sorry. Okay, where was Alan Turing born? Alan Turing was a British computer scientist, blah, 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 right? So each of these documents is getting combined with this, and we're outputting that as an encoded form. So some of these encoded forms may actually have the answer that we're looking for. Some do not, right? So you can imagine, I just asked about where Alan Turing was born. Some documents just might have Alan Turing in it. Okay. So in the last part in the decoder, we're taking advantage of the cross attention in the decoding module in a transformer to come up with the answer. Okay. So that's the key of this paper here, is to do this part to encode and then concatenate all the passages together. And this entire section, right, this part over here, this part is the tunable part, right? Because we're looking at the encoder section and the decoder section as parts of a transformer model that can be revised. Okay, so that's the part that's being optimized. Okay, so that's the first paradigm. Another paradigm is this idea of looking at tuning a little bit more than just the generator, but also the retriever model. Okay, so I'm just going to give one example of that. So the FID method that we showed on the last slide, this one has some drawbacks because you look at this, every time we get another document, we have to encode all of this out. So the encoding, if the passages or the documents are long, it could take a lot of time to encode. So we have to spend a lot of extra time doing all of this, encoding all and concatenating all of that, to read all of that in context to decode what is usually a very short answer. If you look at the answer on the previous slide, right, it's only like 3 words. Okay, so to get those 3 words, we have to encode the query, encode the documents, and then decode all of that out. It's very expensive. Okay, so in doing the optimization, in this case here, what we're doing is we're truncating the passages. So here, for example, we might just say we cut off after X number of tokens. Okay, so we limit how big some of these encoding blocks can be. Okay, so the idea is we get the benefit of having lots of passages, but we only encode the top parts of each passage. And then we use the cross attention coming from the concatenation to do a better job of decoding. Okay, so doing that, even though we have, let's say, 40 passages, again, the decoding time where we're passing all of that in here, because we have to put all of these tokens, we have to run the decoder auto regressively through all of those tokens. Okay, will take a lot of time. But when we truncate it, the 40 passages to a smaller amount, then it takes very little time because the representation that we have for each of those passages is very short. Okay, so then the latency drops from this much to this much, so it's a fairly large savings. Okay, the Haitao also mentioned re-ranking, so we can also do the re-ranking part here to figure out which of the documents has a higher chance of having the useful pieces of information, and also using a context pointer to tell us which document generated which part of the answer. Okay, and over time we can again learn which document sources might have more useful information, and then try to disregard the documents that are less likely, so that we don't have to encode a lot. So the idea is just like Haitao said, when we have a lot of documents to retrieve, we do a first passage retrieval, but then we do a re-ranking to throw away a lot of documents that we don't think are very useful to really represent what to decode. Okay, so that's the idea behind this optimization. Okay, one problem with a lot of these models is that the generator parts of these things, they are not, they're discrete, they're not continuous. Okay, why does that matter? So if you're an undergraduate, you may not understand it, it's okay right now. By the time you come to the end of the course, it should be very clear. A lot of the models that we train need to be trained in a continuous manner, meaning the signals that they have cannot be binary 0 or 1. They have to be continuous loss. Okay, these loss functions have to be on a continuous value scale between positive 1 and 0. Okay, so that's helping to differentiate loss, and it helps us to do the optimization, right? So if you know about stochastic gradient descent, it requires a differentiable loss function. Okay, so the way that we're doing the retrieval now is things are either relevant or not relevant, right? So it's 0 or 1. You either get it right or you get it wrong. So the idea behind this paper is very simple. It's just add some noise factor so that we get continuous values out of that. Okay, so this is a very common practice when you have discrete values, okay, like ones and zeros. Then you find some way to noise it by either adding Gaussian or Gumbel noise or some other noise, so that suddenly everything magically is continuous, even though it's noisy. Now suddenly we can do optimization. Okay, so very nice trick. Okay, so we can do this even in this case where we have binary information. Sometimes we have preference information, like Haitao mentioned earlier. We prefer document A over document B. So you would say prefer A, but now we're going to noise it and say you prefer A 90% of the time, something like that. Okay, so now we can train a system to be able to do standard gradient descent methods for doing this end-to-end retrieval. Okay, so I think in the interest of time, I'll just mention this last paper where we are doing something that I think a lot of people are interested in, which is now doing reinforcement learning, right? So the whole point of reinforcement learning is to make use up a lot of electricity, like I like to say, it's basically trying to learn by itself, okay, by representing everything as in a search state, right? So here we are viewing all of the different actions that we can do as an operation, and we need to learn a policy, right, about what action to do, right? So we can either answer the question or instead to go search. So remember the first part of the lecture that Haitao gave, which is about when to search, what to search for, right? So here we're trying to learn that through a reinforcement learning paradigm, right? Casting it as a reinforcement learning problem. Okay, so reinforcement learning will eventually know that because you've got the reward for getting the right answer, or you've got the reward for making a search, then it will learn over time which actions to do. So you can answer the query, the question of what to search for or when to search for using, its own simulation, right? So reinforcement learning doesn't need in some cases doesn't need a direct reward signal. You can generate this from a proxy. Okay, so then we move all of these into this state action observation cycle. Okay, which if you're interested in RL, we can explain more about. But today it's already 8 o'clock. It's late, so we'll skip the details. But just to know that a lot of what you hear about AlphaGo 0 or other things like that, where you're learning just by simulating things, does also work for our age. Okay, so with that, actually that comes to the end of this section. So I took too long for the Kahoot and explaining the course logistics, but that's necessary. So we're going to end the lecture part today. So let's thank Haitao for the lecture. Okay, so those of you on live stream and not doing lecture week 2, you guys are finished for today. For those of you staying back,